Our goal with this lesson is to be able to factor a polynomial like this p of x, 2x cubed minus 5x squared minus 4x plus 3. The reason we want to be able to do that is because if we get this in factored form, then we'll be able to know more about the graph. So in order to do that, though, we have to use this factor theorem. And the factor theorem says that if x minus a is a factor of a polynomial, x minus a is a factor of a polynomial if p of a equals 0. Because remember, p of a equals 0 means that when you divide by that polynomial, the remainder is 0. And if you divide something and you get a remainder of 0, then that means it's a factor. Just like if you look at a number like 6, and you want to talk about the factors of 6, well, they're the numbers that divide evenly into 6. 1, 2, 3, and 6. Because when you divide 6 by those numbers, you don't get a remainder. So that's what this is saying. That is that x minus a is a factor if p of a equals 0. And p of a equals 0 means that the remainder is 0. Because remember, p of a gives you the remainder. We have the integral zero theorem, which says the factors of a constant term of a polynomial are potential zeros of the polynomial. So that means if we're looking for possible factors, we're going to look at the factors of the constant term. So for this one, the ones that we're going to test, so potential zeros, would be the factors of 3. So potential zeros of this polynomial are positive and negative 1 and positive and negative 3 because those are the factors of 3. There could be other zeros as well, but they wouldn't be integers. And we want to try to find factors that are integers. So this is useful in factoring polynomials because it helps us find the zeros, which then give us the factors. So now if we look at factoring this, potential zeros, like I said, were positive and negative 1 and positive and negative 3. Those are the ones we're going to test and see if they are factors. But I'm not going to divide by x plus 1 and x minus 1 and x plus 3 and x minus 3 and see which one divides evenly, because that would be too much work. I'm going to test them using the remainder theorem. So I'll figure out what p of 1 is equal to. So that's going to be 2 times 1 cubed minus 5 times 1 squared minus 4 times 1 plus 3 is just filling 1 in for all the x's. I'm always going to test 1 and negative 1 first because they're the easiest. What am I looking for as an answer here when I simplify this? I want a 0 because I want it to divide in evenly. So this comes out to 2 minus 5 minus 4 plus 3, which is equal to negative 4, which tells us then that x minus 1 is not a factor. So I'm not going to try to divide by x minus 1. So I'll try filling in negative 1. Oops, that should be a negative 1. So that comes out to, let's see, that's negative 2 minus 5 plus 4 plus 3. What does that equal? 0. So once we have a 0, I'm not going to test the other two numbers. I'm not going to test 3 and negative 3 because I found one of the zeros. Now 3 or negative 3 would probably also work, but I don't need that. I found one of them. I found negative 1 is a 0 of that polynomial, which means if I were to graph it, it would cross the x-axis at negative 1. It also means, based on the factor theorem, that I'm going to say, therefore, x plus 1 is a factor. So now I'm going to take that polynomial and divide it by that x plus 1 factor. So I'll do -1 into 2, -5, -4, and 3. Bring down that 2, multiply, add, multiply, add, multiply. Remember all this. Remainder is 0, no surprise there, right? We already knew the remainder was going to be 0. But what that gives us now is this polynomial that we started with up at the top, we now know is equal to x plus 1 multiplied by what I get here, which is 2x squared minus 7x plus 3. So it's partially factored. Now I just need to factor this 2x squared minus 7x plus 3 to get all three factors. So the x plus 1 is still going to stay there. And then I need to factor, that's going to be 2x, x.
But if you already know that you're going to...
So here's the factored form of that polynomial, which is what this question was asking us to do. But now that we've done that, we can also talk about some of the other characteristics of what the graph of that function would look like. So we could say, well, it's cubic, and the leading coefficient is positive. So it's going to go down into quadrant 3 and up into quadrant 1. It has 3 zeros. It has a 0 at -1, at 1/2, and at 3, all with a multiplicity of 1. So we could get a good idea of what that function looks like now that it's in factored form. When it was in its standard form at the top, all we really knew was, all we can really tell is, well, it's cubic. We know we know the end behavior, and we also know the y-intercept. Do you know the y-intercept of that polynomial function? It's at 3, right? Yeah, it's the constant term. You can find that out at the bottom just by multiplying 1 times -1 times -3, and that'll be the constant term. So you can still tell that. Here's another one. I'm going to get you started, and then I'm going to let you work on it. Let's look at what the potential zeros are to start with. 1 and 2, right? So positive, -1 and positive, -2 are the potential zeros. So I'm going to do P of 1 that works, doesn't it? 1 cubed minus 3 times 1 plus 2, so that's 1 minus 3 plus 2. So there we only had to test one of them and found the 0. 1, 0. So what is the factor then?
Negative.
Right, x minus 1. So we'll say therefore x minus 1 is a factor. So I'm going to do the synthetic division here with 1 on the outside and 1, 0, -3, and 2 on the inside. Did you remember to put the 0 in?
Yes.
Good. Bring down the 1, add those, multiply. If you get to this point and you don't get a remainder of 0, then you should know that you made a mistake somewhere, right? Don't keep going if you didn't get a remainder of 0. Go back and find your mistake. But now what we have is that this P of x is equal to x minus 1 and x squared plus x minus 2. And then we need to factor that quadratic. So we're looking for two numbers that multiply to -2 and add to 1. So x plus 2 and x minus 1. So really I'd probably should write that as, is this what you got first of all?
Yeah.
Yeah? Did you rewrite it? With x minus 1 squared? X minus 1 squared times x plus 2. And now if we start thinking about the graph of this one, again it's a positive lead coefficient and it's cubic. So it's going to go down and up. It has a 0 at -2 and at +1. So it's going to come up here, down, just touch there and back up. Right, and how do I know that it just touches at 1? Well, it doesn't quite look like it the way I drew it, but it comes down and just touches at 1 and goes back up. Why is that? Has a multiplicity of 2.